two things. One is time series, other one is the spatial. Okay. If anything on spatial, I think the physics-based numerical model is doing better job. But if you want to go for time series, local rhythm, then AI is better. So we need to integrate, or we need to fuse both together in order to understand the local weather in a fine scale. When you want to go, suppose Cloudbursts is there. So you cannot do only with numerical model and with AI also. So we need to blend both. That is more important. So we want to go for high impact weather events, how to predict, especially cloudbursts and other things. We don't know how to predict. So that is why we are looking at whether AI can help or not.
If you want to make a model for serving extreme weather related issue that is hyper local, then all the spatio-temporal aspects, all the variety of modeling aspects, all the prediction algorithms, those are the things that we will bring in. But we will not be building on the top of large language models or so-called foundational model, which come with a lot of baggage. You don't know what kind of data it has been trained on, many other things. So original research in creating new, small, agile models, so it will be a platform on the top of India AI structure to be able to create models. And one area in which we would love to create models, we have technical expertise here, Dave and many other people, and we can, so earth science, including disaster, including, sustainability issues, is one of the vertical. Other two are health and pharma. Pharma, we have very strong partnership with Indian Pharma Alliance, and there are 23 major pharma, which is 80% of India's pharma, kind of output. And similarly, we are working with some health partners and all. But here you see the potential partners that we could have in making impact into the sustainability and health area.
India is transitioning from a fossil fuel-based economy to a renewable energy power-based economy, and renewable energy is dominated by solar. Right now, if you look at the kind of models that are becoming available for hyperlocal forecasting, they are also giving us much more predictive power in terms of how much energy will one rooftop solar panel generate, which is critical for managing the grid. Right? India's grid needs to be digitized, and in fact, we have a team from IAIRO University here which is doing a demo on combining digital public infrastructure from the Ministry of Power, which is India Energy Stack, combined with AI models which use weather forecasting and do forecasting about grid loads to be able to trade energy between consumers and producers.
Beyond that, the other advice is that you have to start thinking about segmenting the market that you're targeting. So there is the general population, and that again goes through the government. There is that funding, I think, as Dr. Shivkumar said, has to come in a public-private partnership, because collaboration, I think, is the important word you used. And I think that collaboration is both on the deployment side, but also on the funding side. So it's great to see what the government has done with ANRF, with RDI, and that capital that is becoming available. There's also philanthropic capital that is actually now becoming available in this space. So there are philanthropists that are looking at programs at scale and saying, okay, if this program can scale, we'll put money behind it. So that's one part. But the other segment is that you have to also think about where is monetization possible. And there are enough segments where core business is getting impacted because of weather or other events, right? And that core business is willing to pay. So you have to therefore segregate the two. In some ways, if you think about it, you are building for a public good, but the distillation of that allows you to build something for private good and charge for it.
What I'll say is that weather is the tragedy of commons. Everyone is affected by it, but no one can pay for it. And the same way, when we have to have institutional investments, the question comes up, how do you make this into a monetizable product? And this is where the issues, like, today morning, the Director General Mohapatra mentioned that we can create some box models which are very simple, scalable, and transferable. And we can create digital twins which are very decision specific. We don't need to predict every variable at every scale for everything to try to do that. So if we define why we are creating models, what decision we are going to guide based on that data to decision framework, we can make that into a very intelligent, scalable modeling system. And that, I think, is where the joy of bringing AI and the physics and the human decisions and dimensions come into picture.
So I'll touch on three things. One is, I think, creating the benchmark data sets and benchmark metrics that are needed to achieve operational quality. And if you look at what has led to the developments at the global scale at 25 kilometer resolution, is the ERA5 dataset from ECMWF and the benchmark problems that they've defined on that dataset, like weather bench, for example. So I think if we want to get down to the hyper-local scales, which of course depends on the region that you're talking about and the types of metrics that you care about, it would be very helpful to create the benchmark datasets and the associated benchmark metrics that can drive towards that. And if we just wind the clock back, the whole AI revolution in deep learning began because of ImageNet, and that was 12 years ago. And they defined benchmark datasets and benchmark metrics that drove the revolution in AI. So I think we can do the same thing if we take it down to the hyperlocal level as well. The second is to leverage the super resolution techniques that AI has shown to be very powerful. We're already doing that right now in the Earth-2 program with taking 25 kilometer data and super resolving it to 1 kilometer. That's also, we've been doing this in weather climate for decades with downscaling, the process of taking coarse resolution simulations and making high resolution. So if we can stretch that even further to go down to these hyperlocal scales, I'm fairly confident that the technologies needed in generative AI to get us to that scale are either already exist or will be invented in the next 2 to 3 years. So,
secondly, the way the hazard scenario has unfolded in the last few years, it has become a multi-hazard, cascading hazard sort of scenario in which one hazard leads to other hazards. So there are incidents of cloudbursts which are currently cannot be predicted because of there are various technical issues also behind it. But cloudbursts leading to landslides, leading to flash floods are a serious concern. So how do we prepare ourselves given the current state of resources and the developments? And this is where AI can definitely pitch in. So the idea is actually to get the various from the alert generating agencies all the data which are coming from our terrestrial, the satellite data, the sensory data, and then to be able to use it for predictive forecasting or also to better the nowcasting, to increase the granularity of the even the early warning signal, because there are limitation of how many satellite systems we can put into place. It is not possible to map each and every the hill in the vulnerable areas. So this is where the complications arise, and since development also has to take place in the vulnerable, particularly in the Himalayan zone, so the challenge is here to use technology at the maximum. What I foresee is that the availability of the data from various multiple sources can definitely be analyzed and used for, even with the current set of sensor network capabilities, to predict, or rather to pinpointedly and accurately predict the forecast, the early warning signals for the targeted population, and then it will help the district authorities, the state authorities for timely evacuation and response and relief operations to be carried out. So
models that are coming out, I mean, one is the time series model, there are spatial models, and I will also mention that today with generative AI you can just put a camera pointed to the sky, and then you can actually not only see the patterns of clouds, you can forecast 1 hour ahead, 2 hours ahead, even 4 hours ahead. If I change the camera, make it an IR camera, make it some other multispectral camera, then all the costs are dramatically dropping. So you can imagine a network of sensors that complements also the great work that's being done in Mission Motion and so on. And plus now with the low Earth orbit satellites going up and also having much more Earth observability, I think the opportunity to fuse insights as opposed to fusing data. I mean, data fusion is a painfully, mind-bogglingly complex, unnecessary complex thing. But now there's an opportunity to take insights from A, insights from B, and fuse it across modes, and also forecasting across these modes. I think that's a wonderful opportunity. I think that will have a huge thing. Once you integrate that into, nowcasting and other systems, I think we can